Hi, this is Alex Shear from Ohio State's Game Creation Club. This is the first episode in a series of Unity tutorials where we create a 2D platformer. While this is episode 1, there was an introduction video which covered kind of the basic overview of the Unity editor, as well as just highlighting what we're going to be creating during this tutorial series. I highly recommend that you watch the introduction or episode 0 first before watching this video. That being said, let's go ahead and get started in creating the basic player movement for our game. Now, this is going to be the first work we actually do within the Unity editor. So the first thing we're going to do is create a game object for the player. Now, there's multiple ways you can create game objects, but the simplest is going over to the hierarchy window, right-clicking, and doing create empty. This is going to create an empty game object. As you can see, it just calls it game object. If you want to rename it, you can either right click and hit rename, or you can go over into the inspector and rename it at the top here. If you remember from the previous video, when you click on an object in the hierarchy, it's going to go ahead and show its details in the inspector. And the only component that the game object has currently is this transform component, which gives it a location. Now, while I said this is the simplest way to create a game object, this isn't actually going to be the way we're going to create a game object right off the bat. We're actually going to go ahead and click this game object and click the delete key. You can also, by the way, undo in Unity by hitting Ctrl-Z, and the reason I'm doing that is to show that you can also just right-click and hit delete. The way we're actually going to want to create the player is by first creating a sprite. So down here in the project window, and remember this is kind of like the file explorer, this is where all the sort of files for our project are going to be held, we're going to create a new folder. So right click and go to create folder, and we're going to call this sprites. This is where we're going to keep our sprites for this game. Now, you don't actually need to create a folder for this, but it's important while creating games to stay organized, which is why I highly recommend it. So go ahead and double click on this sprites folder, and now we'll go ahead and open up the folder, and now we're going to create just a very basic sprite for the player. So go to right click here, go to create. We're going to go down to sprites, and then we're going to select square. Now, the reason we're doing this is we're going to just make a default sort of square sprite to create our player, and we're going to worry about giving the player its actual texture and correct sprite and look later on once we get to that portion. But for now, our character is just going to be a square. So you don't even have to worry about renaming this just because it's a square sprite. If you have your own file or image that you're wanting to use for the player instead of just a square to start, you can either just drag in that file into this folder or go up to assets. You can either click show and explore, which will open up the actual explorer so you can actually see the assets folder, and you can see we have the scenes and the sprites. Don't worry about these meta files. These are important. Unity uses them to keep track of meta information about each object and folder. They're not important to us, and we're never going to use them, but it's important not to delete them because it can mess up things in the game. You can either add sprites in here or go up to the top as well and use the import new asset. But really the easiest way is to just, like, if you have File Explorer open up and you have an image, you can just like drag it into the project window directly, and Unity will handle importing it. Again, we'll show some of this later on, but if you don't want to use this square just to start, that's some options. But anyway, now that we have this square sprite, I mentioned you can create a sprite by a game object by right-clicking and hitting create empty. The easier way, or not the easier way, but the better way to do it for this 2D platformer is you're going to just, from the project window, click and drag on the sprite we created, drag it up to the hierarchy, And as you can see, it created a new game object. It called it square because that's what our sprite was called. And you can see it has one more component than last time, this sprite renderer. This is what actually causes it to show up on the camera. So if you see in the scene view, we now have this square in the actual game. And if I click the game view, you can also see it right there. So this is going to be what our player is. Now, it definitely doesn't look like our player right now, but again, slow steps to start. So the first thing we're going to want to do is we're going to want to create sort of movement for our character. So if I go ahead and hit the play button, remember there's this play button up at the top that you can use to play Unity games. Currently, it's not doing anything, this player. It doesn't do anything if I hit any keys or if I click, and that makes sense. We don't have any components on this object that would actually cause anything to happen. So if we're going to want this to act like the player, we're going to have to start writing some scripts. I am going to go ahead and rename the player. I'm going to just call this object player so it makes sense. We know it's the player. And then I'm also going to save our scene, and you can just do that by hitting Control S. If you see at the top with the scene name, the default is sample scene, and there's this little asterisk that tells you that you have unsaved changes in your scene. So if you hit Control S, it'll save, and this default scene is located in this scenes folder. Okay, let's get started and actually writing some code that will control the player. So if I go to the player, we're going to add a component. There's this button at the bottom of the inspector to add a component. If you go ahead and click that, you'll be able to notice, I already have some text that I was searching for last time. This is the component menu. There's a lot of default components within Unity that you can add, and they're broken up into these different sections. There's a ton, and we're not going to hit a large majority of these because Unity is super powerful and comes default with a lot of components. But it's just important to know that there's a lot here that you can use. We're actually not going to be using any of these default components. We're actually going to be using a custom-made component, which we're going to use by writing our own script. You can scroll to the bottom and click New Script, or the way I like to do it is I like to, up here you can search for different components, but I actually like to type the name of what I'm going to call my script. So I'm going to call this script player controller, and you can see it didn't find any components called player controller, so it gives us an option to create a new script, and then by default it calls it what we were searching. We're going to create a new script called player controller, and then you click create and add, and that will do two things. The first thing it's going to do is it's going to add this player controller script, and you can see there's not much in it. There's no other like options and stuff within this script, and you don't have to worry about that right now. But the other thing it did is if I go ahead and re-click on the assets, you can see it created this new file called player controller. And this is the actual script. So while it's attached to the player as a component, the actual script for it is here within the assets. And if I'm in a different menu, you can see if I click script within the inspector, it actually highlights where it is in the project window. So I'm actually going to create a new folder for scripts. And again, this is just to stay organized. And then I'm going to click and drag the newly created script and put it in there. The next thing I'm going to do is I'm going to double click the player controller script that we just made, and this is going to open it up in whatever code editor you used. Again, in the introduction, I mentioned I will be using Visual Studio Code, but feel free to use whatever code editor you prefer. Now, Unity is going to, by default, have this default script that it puts in. And this is just sort of a default placeholder that will help sort of organize your code. You can see that it is a class called player controller. it actually extends this other class called monobehavior. If you are familiar with Java, you might see class extension before instead of this colon sign as the word extends. You don't have to worry about class extensions or anything at all, but if you do know anything about coding, essentially this monobehavior is a Unity class that all of our custom scripts are going to inherit from, and it just gives it nice properties that actually allow it to work within Unity. But it comes with two scripts to start with. And these double lines indicate comments. So these aren't actual code. These are just comments that tell us information about the code. There's the start function, which is, as it says, called before the first frame update, and then update. Code you write within update is going to be ran every single frame. So for stuff like player movement, we're going to write that in the update function. So the player moves and is updated every frame. One thing to note as well is that within C#, which is the language we'll be writing our Unity scripts in, is that there's no requirement for braces, whether you keep them on a different line or the same line. Some people have their own preferences, but me personally, I like to keep my braces on the same line. This is not important at all. This is just my preference, and everyone has their own. So the way we're going to first kind of cause the player to move is we're going to move the transform of the player. If I go back to the Unity editor, if you remember, if you click player, this transform component is what controls the location of the player. So it has a position, a rotation, and a scale. You can click these and adjust your own values. So I can type 1, 2, 3, and you can see the player move on the screen. What you can also do is if you hover over the actual label of the field, you'll have a little slider. So if you click and hold, you can actually drag and it'll adjust the values that way as well. So that's how you can move the player within the Unity engine, but how we actually want to then use that to move the player in our code. I'm also going to increase the font size so it's easier for you guys to see what I'm actually coding. Alright, so now let's actually get our player to move. So within the update function, we're going to write transform. And now transform is a shortcut to get to the player's transform component. And if you remember in Unity, if I go ahead and click on the player, the transform has a position, rotation, and scale. And we can actually access these by doing transform dot position, rotation, and then it actually doesn't have scale, it has local scale. That's just how it's named, and that's because of how you can nest things and how the scaling works. But anyway, we're going to just care about changing the position. But if you're making a game where it's important for the player to rotate, you can also update that as well. So now what we're going to do is we're going to change this, and we're going to set this equal to, we're actually going to set it equal to the transform position itself, but we're going to add an amount of movement. Now, if I hover over transform.position, you can tell us, it tells us that this is a vector 3. If you know anything about math, and it's okay if you don't, vector 3s are essentially 3 numbers. These are going to be like decimal numbers. So, and this is going to determine the X, Y, and Z position of our object. Now, this may sound confusing for a 2D game. Why do we have an X, Y, and Z to define the player's position? And that's because of, like I mentioned in the introduction, Unity is a 3D engine. Even though we're making a 2D game, you can see that it's actually 3D. And that's why it has this Z position. But if I go ahead and adjust the X and Y, you can see adjusting the Z doesn't do anything. It does stuff behind the scenes, but from our camera's perspective, it doesn't actually do anything. But anyway, so we're going to transform this with, we're actually going to create a new vector 3. So this takes in 3 integers. So I'm going to increase it by 1, 1, 0. So what this is, and I do need a semicolon at the end to say it's the end of the statement. Essentially, I'm going to be adding 1 to the x, I'm going to be adding 1 to the y, and I'm going to be adding 0 to the z. And we don't really care about the z again, but we have to have this because of you have to have a vector 3 in order to add it with a vector 3. You may be wondering if you can just use transform.position, and you can actually access the x and y directly by doing .x and .y. And if I can do this, plus equals 1. And you actually can't, the way vector 3s work, you have to rewrite the entire value. You can't just rewrite one of them. And also, I introduced a bit of shorthand here. Plus equals is just the equivalent to if this was equals and then itself plus 1. So I'm actually going to change the line above to include this as well. So instead of transform.position equals the current position plus this, I'm actually going to change this to a plus equals, and then I can remove this part. So essentially every frame, it's going to be adding 1 to the x and 1 to the y. And importantly, it's going to be very important for you to save your work, and that you can do that by hitting Control S. Well, it's going to vary from editor to editor, but every editor, it's Control S to save. And it's just important because of you'll often get into times where you forget to save and be wondering why something's not working, and it's because you haven't saved. So if I go back up here and hit play, well, our player's gone. I don't know where he went. You may have seen him for a brief second. He actually left screen immediately, and that is just because of we are adding so many and we're doing this every single frame that the player is just moving way too fast. So let's try decreasing this by a lot. Let's try 0.01 and 0.01. And well, the way C# works, because these are floating point values, meaning they have a decimal, you just have to include an F at the end, so it is fine. Again, if you're not familiar with kind of these object-based programs, it may not make sense to put this F, but it's just something you have to do when you're writing in values that have decimals. But once again, make sure you save, otherwise none of the changes will actually apply. And then you can see, you may have been able to see briefly, I couldn't hit play. And down here in the bottom right, it's very small, there was like a little loading icon. And this is just because of it takes a while for the code you actually write after you save to compile and update. It varies how long from machine to machine. But if you ever get into a scenario where you can't play after you change a code, it might just be compiling in the background. It will take a couple seconds, but then you can play. And there we go. We can see the player was moving. So now kind of the thing we want to do is adjust the player's movement based off of our actual input. So kind of a way many people starting off will do this is they'll write like an if statement, and they will check to see if the player is holding down a certain key, and then if they are, they will change the transform by a certain amount. So for example, if they want to move left, they'll do like, actually this would be right, but no bother. Also, in this sort of first line of code, we're going to introduce the first actual sort of user input. So if you guys know coding, in this if statement, the code in this block will only execute if a statement is true. So we're going to do it to see if they're holding down the left, or in this case, the right arrow key. And the way in Unity you do that is just capital I input dot get key, and then in parentheses, and then in the parentheses you're going to do key code dot, and then whatever key that you're looking for. So we're looking for the right arrow key. So in this case, it's right arrow. And this will return a Boolean, either true or false. It will be true if the player is holding down the right arrow, and it will be false if the player is not. And then If the player is holding down the right arrow, then it will add this amount to their transform. So let me go ahead and hit save and hit play. So you can see the player's not moving. I hold down the right key and then the player moves. And you can easily imagine I can add another line where instead I check the left key, and then instead of adding positive 0.01, I would add negative 0.01. Or maybe I would actually just subtract positive 0.01. Either of these would work. And either of these do give you movement. So if you're wanting to do movement like this, this is a way. However, it's also just not the cleanest way you can write movement code. And in fact, with Unity having sort of a built-in physics system, this is actually not how we're going to be doing our user movement. You may be wondering, why did I just talk about this for a couple minutes if this isn't actually the movement that we're going to be using? And that's just because it's important to know that you can easily access the player's position by using this transform.position. And in many games that you may make, maybe you don't want physics, maybe it's a top down and you want to be able to move the character in all directions, then this is a perfectly valid option for how you want to do user input. It all depends on what type of game you're creating. But anyways, I'm going to go ahead and delete that, and instead what we're going to do is we're first going to add a component to the user, or the player. So if I go back to Unity, click on the player, I'm going to add a component, and I'm going to search this time for rigid body. Now you can see there's two options, rigid body and rigid body 2D. If you were making a 3D game, you would add rigid body, but since this is a 2D game, it's going to be rigid body 2D. So if you go ahead and click that, it's going to add a rigid body 2D. Now what this does is it gives our player physics. This is what causes the player to interact with other physics objects within our game. So what it's going to do first is it's going to, by default, add gravity. If I go ahead and hit play, and remember, we already removed all of our code, so none of our code here is actually doing anything. But if I go ahead and hit play, you're going to be able to see that the player fell, and that's because it's affected by gravity now. So one thing that we're going to want to first do is sort of create some ground. So I'm going to go back into our sprites, going to re-click our square and drag it in, and this is going to be our ground. So I'm going to rename it ground. You can see, actually, well, you can't see it. You can't see the ground because it's the exact same size and shape that I made the character, but with the ground selected, I can click and drag the ground away. And this was an important time to sort of talk about kind of the different cursor modes that you can have within Unity. You can see up in the top left-hand corner, when I hold down the scroll wheel or right-click to pan, it switches to that pan tool. There's also a move tool that looks like this, where you can use these arrows to move different objects. There's also a rotation one, a scaling tool. This rectangular tool is very useful for 2D games, and actually the tool we're going to use right now. One way you can easily switch between all of these tools without actually going up here and clicking on them, if you use the top row of letter keys, so QWERTY, so Q, W, E, R, T, Y, those will actually switch between all of the ones. So you can see at the top, I'm not actually clicking them, I'm just hitting QWERTY. This doesn't come up very often, and in fact with 2D games, often you'll just keep it on the rectangular tool and then use the mouse wheel or right click to pan. But the nice thing about the rectangular tool is you can stretch. So if I click on the side, I'm going to stretch this into some ground. So this is going to be the ground for the player. I'm going to hit play, and you can see our player fell through our ground. So why is that? It's because of, while the player has a physics rigid body. This means it's going to interact with physics. The ground doesn't actually need a physics rigid body, which may sound counterintuitive. I said rigid bodies allow it to interact with other physics objects, and while that is somewhat true, it applies physics to the objects. What we actually need here are hitboxes. This is what is going to kind of cause the collision between these objects. In Unity, these are called colliders. So to both the player and the ground game objects, I'm going to be adding what is called a box collider, or in this case, a box 2D collider. So if I search for box, you can see it pops up box collider 2D. In this, you don't have to edit any of these settings, but if I scroll in, it may be very hard to tell, and maybe if I click in between having this enabled or disabled, but there's it adds a small little light green outline around the box, and that just sort of shows where it is. Actually, let me disable the sprite renderer real fast. There we go. So by disabling the sprite render, it's no longer rendering the sprite, but you can see this little box, and that is our box collider. This is the hitbox of our player. I'm going to also add one to the ground. And now both our player and the ground have a box collider, and when I hit play, you can see the player actually fell and hit the ground, and it stopped on the ground, which is exactly what we want. By the way, if you are wanting to kind of change what the collider looks like, there's different collider shapes, but you can also click here and edit collider, and then there's these small little squares that are probably hard to see depending on what screen you're watching this on, but you can click and drag them or edit the values over here. But for here, we just want them all the same. And I think actually I was supposed to set this to 1, not 0. Whoops. Anyway, once again, if I hit play, the player falls and hits the ground. So now we're going to want to apply physics to the player. So now we're going to want to apply player input. So now we're going to want to use user input to apply forces to the player. So if I go back to the code, now I am going to show a way where you can use these forces to change the position of the player. But once again, this isn't actually the final sort of physics thing we're going to be using, but it is an important thing to sort of show you how you can use this for other games. So I'm going to have what I had before of if input dot get key, and then it's key code dot, if it's the right arrow being held, then instead of adjusting the player's transform, what we're actually going to do is we're going to add a force to the rigid body. Now, the only thing is we don't have access to this rigid body component. So if I click the player, we want to get access to this rigid body component. If you remember, with the transform component, we could just type transform, but we can't actually just type rigid body 2D. This does have some pop-ups, but this isn't something we have access to. This is just the class name. We have access to the transform by default because of we extend this mono behavior, and all Unity objects come with a transform component by default. But with rigid body, that's not the case. So in this case, we're going to have to actually get the component. And there's a very useful function within Unity that we're going to be using all the time called get component. And get capital G, capital C. And then we're actually going to use what are called angle brackets. So it's a less than sign and then greater than sign. And then in between those signs, we're going to type in rigid body 2D, capital R, capital 2D, although you can't have capital 2, I guess. And then we're going to finally end it with this left and right parentheses. So what this is doing is this is going to be returning the rigid body 2D component on our player. Whoops. So it'll actually return this rigid body 2D component. And then what we're going to do with that is if the right arrow key is being held, we're going to add a force. So there's a function on rigid body 2D called add force. And the input for this, again, if I hover over it, you can see that it's a vector 2. It's a vector 2, not a vector 3, because of rigid body 2D knows, because it's 2D, that it's actually going to just take a 2D force. So I'm going to, again, instantiate or declare a new vector 2. And in this time, it needs two inputs, the x and the y value. So the x value is going to be, let's say it's just 1, because it's in the positive direction. And by the way, I should have probably mentioned this earlier, within Unity, to the right is the positive x direction, to the left is the negative x direction, up is the positive x direction, and down is the positive y direction. And that's easy to see if I increase or decrease the x on this slider and y on this slider. But I'm going to add 1 and 0. And then remember to add a semicolon at the end. If you don't add a semicolon, or if you have any other errors in general, Unity, when you try to hit play, will tell you that all compile errors need to be fixed before you can enter play mode. And then actually, if you go down here, it's next to the project window tab. There's a console window, and it will actually tell you here what the error was. So make sure you have semicolons, or if you have any other errors, it will tell you here. So let me go ahead and save, go back here, and then when I hit play, when I press the right arrow, nothing's happening. So why is that? The basic reason is because of friction. Unity is creating friction, which is causing it, the force I'm adding is not enough. So let's increase it to 10. Let's see if that works. And again, it's compiling first. Yep, it was enough, and it was too much, in fact. So you can already tell it will take a while if I kind of come back, go back and forth. Let's test 5. Let's see if this works. And I have to wait for the code to compile every time. This would take a long time if I'm just trying to find the right number. And the way you can sort of fix this, and a really cool thing about the Unity editor, is that if you remember with the other components, for the example, the transform or the sprite render, they have all of these options that you can change. But our script, the player controller, doesn't have any of these. But we can actually create our own variables that we can adjust in the Unity editor within our script. And the way we do that is by declaring a public variable. So if I go up here and type public float, and float is just going to be the variable type, and floats are just a decimal number, and I'm going to call this movement speed. And I'm going to just declare it as 1. And remember, the F is just declaring it as a float. So instead of having 5 here, I'm going to call this movement speed. And now it's the same value right now, it's just using 1, and I could adjust the value here, and it will adjust the value here. But the very cool thing is, within Unity, after this compiles, you can see in the player controller script, I now have access to this movement speed setting. So if I hit play, if you remember 1 wasn't enough to actually get our player to move. Actually, it is moving now. That is weird. Not sure why that wasn't working before. I think actually I might have been hitting the wrong key before, but so 1 does actually work, but if I go to like a lower value, yeah, like this is too small to work. Oh, actually no, what was happening earlier, I didn't have the window focused. I forgot, when you start the game, make sure you click here to make sure it's actually focused, because otherwise it might not actually be taking in the user input. But for example, 0.1 is too small for friction. But I can sort of adjust it. So let's set it to 10. Okay, 10's too fast. Let's try 2. Well, now our player's gone, so I will have to restart in that case. But you can say it didn't keep it as 2. And that's an important thing to note, is that all changes you make while the game is playing doesn't actually get saved when you unpause. So if you're testing values here while the game is playing, for example, let's set it to 2. And you know what? 2 is a bit too fast. I'll maybe 0.1. But the important thing is when you unpause the game, you're going to want to make sure to adjust it when the game is not playing. So I'll adjust it to 1.5. Hit play. And yeah, that feels like good movement. And we might change this later once we get sprites in, but this feels good right now. And the important thing to note is it didn't actually adjust the value here in the code. The code, essentially, you can think of this value as kind of the default. If you add this script to a game object, this will be the default value. But in the Unity editor, this is actually going to override the code. So on this player, it's actually using 1.5, not 1. And once again, you could easily just flip this, call this left arrow, and then add the negative velocity. And you can do that just by multiplying movement speed by -1. And this is a really fast and easy way to do movements. But for me, and with the game that we're going to create, it's a bit too slidey. If you can see, when I hit forward and when I let go, so I'm pressing and I let go, it slides a lot. And that's just because that's how actual physics objects work. If you push something, if you're adding a force and you all of a sudden stop applying that force, momentum is going to keep it moving forward. And for a lot of games that you create, that might be what you want. If you're making a top-down game where you're controlling a spaceship, maybe you want it when you stop applying fuel, you kind of drift for a bit. But at least for this platformer, it's still not what I'm wanting. We're still going to want to use this rigid body 2D, but we're not actually going to adjust the value or the speed of the character by using this add force. Instead, what we're going to do is adjust the player's velocity directly. So I'm going to delete all of this once again, but the one important part that we are going to keep is get component rigid body 2D. And if I hit the dot, you can see that it has a dot velocity. And this is what we're going to edit directly. And the reason we're going to do this is so when the player stops, when the player stops pressing a key, it's going to instantly set their velocity to 0. So there will be no sort of like drifting or sliding. One change I am going to make is because we're going to be calling this rigid body get component a lot, we're actually going to just make a private variable that's going to hold it. So I'm going to just call this, private rigid body 2D, and I'm just going to call it RB for rigid body. Oh, we wanted to autocorrect to rigid body, but no, we just want RB. And now instead of calling get component in the update, we're actually finally going to use this start. So if you remember, this start function is called on the first frame when the game starts. So we're actually going to set our variable to the results of this get component. Copy and paste that over. And now when the game starts, this RB variable will be set to our rigid body component. So instead of calling get component down here, I can just call RB and get the velocity like that. So now it's going to be time for the user input. So we're actually going to set the velocity based off of what the user's input was. Now, earlier I just showed you the input.getKey that can tell you whether a certain key is being pressed, but in this case we're actually going to use something built into Unity called axes. So instead I'm going to do input.get access, and then in parentheses I'm going to add quotes, and in the quotes I'm going to type horizontal, and it's a capital H. Now what this is this is going to get what Unity calls an axis, or a virtual axis. So the horizontal axis, Unity has it default set to WASD as well as the arrow keys. In the horizontal axis, it's going to return a value between 1 and -1 that tells us what the user is pressing. So if the user is pressing right, this horizontal axis is going to return 1. If they're pressing left, it's going to return -1. And this is super useful, so we don't actually have to use get left and get right arrows and then check for each one. We can simplify this into one line called input.getAccess. And then what we're going to do with this is we're going to create a variable, and it's going to be a float, which again is just a decimal value. And we're going to just call this x speed and the x is for the horizontal, or x velocity. And what we're actually going to do is we're going to multiply this by movement speed. So if the player is going to the right, the get access will return 1, but we don't maybe want them moving 1 frame. We want them moving a certain amount, or the velocity to be a certain amount. So multiplying it by the movement speed will just essentially scale this horizontal axis to whatever speed we're wanting. And then in rb.velocity, we're going to just set this to, we're going to create a new vector2. The x value is going to be this x speed we just created, and then the y value is just going to be the existing y velocity. So we're going to just type rb.velocity.y. So essentially, we're not going to be changing the y value of the velocity. We're only going to be changing the x value. So you can already see we greatly simplified this code. We don't even need any if statements, and that's by using this input.getAccess. Make sure you save, and then once it compiles and we run, I'm now going to use the WASD keys, and you can see it's actually working. And the arrow keys work too. So I'm using the arrow keys, and now I'm using WASD. So either work. The movement speed is a bit too slow now that we've changed systems. So I'm going to go ahead and test. Let's try 5. Whoops. Didn't mean to click off of it. Let's try 5. Click back here. Yeah, 5 works. And now what's interesting is that when I let go, so I'm going to hold and I'm going to let go, it might be hard to tell on the screen because you don't know when I'm letting go, but there's still a bit of sliding. And that's because of how Unity handles these virtual axes. So when the user lets go of the right key, it doesn't actually, this value doesn't instantly go to 0. It actually slowly goes to 0. So it'll go from 1, then it'll be like 0.5, 0.2, and it'll like smoothly transition back to 0. This can be very helpful, and in fact, I think it looks really good in a lot of games, just adding a bit of sliding. Not so much that it feels like it's sliding, but just enough to make the motion look realistic. If you don't want that, you can, instead of using .getAccess, you can use what is called getAccess raw. And this will just give you 1, 0, or -1. Where you can easily see this difference is if I'm actually going to show you guys how you can write to the console. So the first line in update I'm going to add to be debug.log parentheses, and then in those parentheses quotes, and in those quotes, actually, nah, I won't use quotes. I will just actually copy over this get input access raw. So what this is going to do is it's going to output to the console every frame what this get access raw is returning. And this debug.log is a very useful way you can write stuff to the console, and it's useful for testing and just seeing what values are. So if I go ahead and make sure I save, compile, and then play, and then look at the console, you can see it's outputting 0 currently. And that's because I'm not pressing any keys. If I press right, you'll see it's now outputting 1. And that corresponds to when the player is moving right. If I go left, it's -1. If I go back into the code and change this to just get access, save, and come back here, you can see if I press right, there's a couple things where it's not 0, it's like 0 point something, and it takes a bit for it to 1. If I go left, it's the same thing. And then when I let go, it's not 0 immediately, it takes time. And that's just Unity's automatic sort of scaling. It's useful to know in case you want to use it, or if you don't want to use it. It's up to you. I'm going to go ahead and remove this debug line. And then I'm also going to go back to Unity. I broke my own rule. I changed the movement speed, and I forgot to change it while the game wasn't running. So let's set this back to 5, which is what the movement speed that we thought was good. The last thing we're going to create in this episode is jumping, and that's going to be done by changing the vertical velocity. So if I go back into our code, I'm going to add another line. Instead of having the velocity be set to just the default velocity, I'm going to create a variable called yspeed. And by default, I'm going to set it to the current value. So right now, the way I have it set up, if I finish changing this to yspeed and add a semicolon, this is doing exactly what it was doing beforehand. It just sets the y velocity to whatever the y velocity was before. But now I have it just set up so it's in this variable yspeed, so I can change yspeed if the up arrow is being held. Now I could do it by doing if keycode if input dot get key keycode dot up arrow. This code would execute only if I'm holding the up arrow. One problem with that is that it's going to, if I hold down the up arrow, it's going to apply it for every single frame that the up arrow is being held. You could get around this by using input.getKey down, and this would only return true the first frame that you pressed the up arrow. So if you hit the up arrow, it would output true, and then for every other frame until you let go of it and press it again, it would be false. But the problem with this is, if you remember with our current movement, using get access, it allows us to use both WASD, whoops, didn't mean to actually type there. It allows us to use both WASD and the arrow keys. So we're actually going to use input.getAccess again, but this time we're going to use getAccessRaw because we don't want any of that smoothing here, and then in parentheses, and then in quotes, capital V vertical. And this is going to give us the vertical axis, which is also set by default for W and S and up and down arrow keys. So if we're holding the up arrow, or W, it's going to return 1 because that's the positive Y direction. So if this is equal to 1, now if you're new to coding, instead of using equals, we use a double equals, and that's because the single equals is used for assignment. So if I'm assigning the variable yspeed this, I use the single equals, but if I'm checking equality, I use double equals. But if the user is pressing up or W, the getAccessRaw for the vertical axis will be 1, and then we can apply our jump logic. So the way we're going to do that is we're going to just set the yspeed to, let's say, 2. Now, this is one way you can set the velocity, but again, if we're wanting to check if we have sort of the right value for the jump, we'd have to go in and update this every time. So we're going to do what we did previously. where I'm just going to copy this and paste it. And instead of movement speed, I'm just going to call this, I'm actually going to call it jump force. I'm going to capitalize the F as well. And I'm going to default it, set it to 1 just because that seems like a good default value. And then jump force, I'm going to replace the 2 down here with jump force. So this allows us to change the jump force from Unity without actually having to going in and editing the code. So if I go back to the code, you can now see the player component has jump force down here, and the default is 1. If I go ahead and hit play and hit up, you can see, ooh, it barely jumped off the ground. Yeah, that's not super strong. Let's set it to 5. That's better. Now, one thing I'm doing is I'm pressing the up key and I'm immediately releasing it. If I hold down the up key, I just kind of float. I can jump as high as possible, and that's because of 2 things. One, every frame that I'm holding the up button, it's going to apply this. There's no get access down. That doesn't work. And the other reason why this is happening is because of we're not checking to see if the player is on the ground. It makes sense that when we're playing a game, we only want the player to be able to jump if they're on the ground. Maybe it's a game where we're programming like a double jump or something, and that could be an exception. But for this, we want the player to only be jumping when they're on the ground. So we're going to have to add kind of a detection to make sure that they're actually on the ground. So the way that we're going to differentiate the ground from everything else in the game is by using something Unity calls layers. So one thing that we haven't talked about within Unity yet is that every sort of game object is assigned a layer. You can tell what layer a object is on by, if you're clicking on it, looking at the inspector, and at the top there's this layer. By default, every layer is set to the default layer. And most times you don't actually need to like go in and set layers. Now this is important to sort of differentiate because this is a 2D game. There's also something known as sorting layer, and that's sort of the order in which things get rendered on screen. So if you're wanting one object to appear on the other, that's sorting layers. Layers, however, are just kind of, it's unrelated to sorting layers, and it's just the way Unity keeps track sort of how things interact, but it doesn't actually dictate how things are rendered. But we're actually going to need to create a ground layer, and then the player can check to see if they're on the ground. But before we actually create that ground layer, what we're going to do is we're going to create another game object, and this is actually going to be nested within the player. So I'm going to right click on the player, and I'm going to click create empty. And because I right clicked on the player in the hierarchy, it automatically nested this game object to the player. Now, this new game object I created, you can't see it on screen that's because it doesn't have a sprite renderer. There's no actual sprite on screen to associate with this game object. But one way you can get around this is inside the inspector, right next to the name, there's this little icon. By default, it's a little cube, but if you go here, you can click kind of an alternative icon, and this will make it show up in the scene view. So click one of these icons, and now you can see where this game object is in the scene view. This is only in the scene view. If I click the game, you can't see like the little icon on it. But this is going to be helpful for us to tell where the game object is. And what this game object is it's going to be useful to detect whether the player is on the ground or not. So I'm going to actually call this game object ground check. And this is what we're going to use to check to see if the player is on the ground. And because that's how we're going to use it, it's going to be important for us to actually set this sort of at the bottom of the player. So I'm going to go ahead and decrease the Y value, and it should be -0.5. If you've adjusted the size or shape of the player at all, this might be a bit different than -0.5. But now you can see that it's at the bottom of the player. And because of the ground check is parented to the player, or it's a child object of the player, if I click the player and drag it around, you can see the ground check, which is again represented by this little dot, moves along with it, with the player. So no matter where the player is, this little ground check is going to follow it, and we're going to be able to use to check to see if it's on the ground or not. Next, we're going to go back into our player script, and we're going to add a couple more public objects. Whoops. So the first thing we're going to add is a public, and we're going to call this transform, and we're going to call this ground check. And then we're also going to create a public layer mask ground layer. And then finally, I'm going to put this at the top because I think it's the most important. We're going to create a boolean, which in C# are called bools and are just true or false values. And we're going to call this grounded. And this is we're going to set this true or false based off of whether the player is grounded. It's important that we define it up here instead of down here, is because later it's going to be important that other things know whether or not the player is grounded or not. But it is important to note that we don't actually have to declare it up here right now. You could have easily as well defined it down here in the update function. Oops, and I forgot I had a semicolon. So what each of these are, I explained the grounded boolean. The ground check is going to be our reference to that ground check object we just created, and the ground layer is going to hold information about what layer is considered the ground. So if I go ahead, hit Control S, go back to Unity, if I click on the player, you can see now within the player controller, because we made these public, they now show up within the Unity editor. You could adjust whether or not the player is grounded or not, but we're going to add something in the script that immediately, with this ground check, we can actually set this object that we just created here. So the script in the player controller script can actually reference this object we just created. And we're not actually referencing the object, we're actually going to be referencing the object's transform component, which is why we made it a transform type. So the way you can do this is either you can go over ground check, click this arrow, and then select ground check from here, and then that will set ground check in the script. The other way you can do this is by clicking and dragging in the hierarchy. You can click and drag it over and hover over here and set it that way. And either of those work. And then lastly, we have the ground layer, which if I select it, these are all the layers in Unity by default. So we're actually going to need to create a ground layer and set the ground to be considered ground. So I'm going to actually go back to the ground that we created, and I'm going to go up to the layer, and you can see that there's an option to add a layer. So if I go here, again, you can see there's a bunch of default layers, but in user layer, I'm going to create one and just call it ground. And if I click away, there's no confirm button, but I did create a layer. But I actually do have to go back to the ground layer. Even though I just created it, it didn't actually set the ground to it. So now when I expand this list, I can now set the ground to be the ground layer. And now if I go back to the player script, I can set the ground layer to be ground. And now we're going to make a check to see if this little ground check is actually touching the ground. And it knows it's the ground because of it's in this ground layer. So we won't confuse it with any other background sprites that we might add layer or enemies. It knows it's on the ground because of we assigned it to be the ground layer. Back in the code, we're going to adjust this grounded boolean by using the ground check and the ground layer that we just created. So down here in between where we set the x speed and y speed velocity, but before we set the actual y speed variable again, we're going to write grounded equals physics 2D, and it's a capital D, dot overlap circle. And then in here, we're going to have ground check dot position, comma, point, let's say 0.1f, comma, ground layer. Okay, so what did I just type? Well, and also make sure to have the semicolon at the end. So what is this? We're calling a default function within Unity within the physics 2D object called overlap circle. And what this is going to do is it's going to kind of create a little circle at a position we provide. It's going to have a radius of whatever we provide here. So it's going to be a radius of 0.1. And it's going to check to see in that circle if it touches anything in the layer we give it. So if you remember, we set the ground layer to be the ground layer. And this ground check position, the ground check refers to the transform of this object, and its position is going to be at the bottom of the player, no matter where the player is. So what Unity is doing here is it's creating a small circle at the bottom of the player. It's creating it with a radius of 0.1, and it's checking to see if it touches the ground layer. And then if it does, it's going to set grounded to be true. And if it's not, it's going to set it to false. So if I go ahead and hit save, you're actually going to be able to see this. And that's because I made grounded a public variable. So if I hit play, you can see while the player is on the ground, it's grounded. And then if I, for example, walk off, it's now set to false. So this is perfect. So all we need to do here is that when we can tell that the player is pressing up, we just have to check that they're also grounded. So I'm just going to add to the end of this and grounded. I'm going to hit save, go back to Unity, wait for it to compile. And now, whoops, well, I forgot to adjust the jump force again, but let's set it to 5 and then hit play. So the player can jump, and if I spam up, it won't actually let me jump until I'm on the ground. And if I hold up, you can see that I'll continuously jump while the player is in the air. Perfect. This is exactly what we want. Now, one thing I am going to point out, and it's not readily apparent, and that's because of our player is a cube currently, is that the player currently can kind of rotate. So if I go off to the edge, I'm not pressing any buttons. The player just slowly kind of falls off. And that's because of Unity is just treating it like a physics square. So it will fall and rotate. Obviously, with the game that we're creating, we don't want the player to be able to like fall over. That would look kind of weird. So the way we can fix this is within the rigid body component in the player, there's settings under constraints. And you can freeze the position or freeze the rotation of the rigid body. And in this case, we're going to want to freeze the rotation. So if I go back to the game, you can see if I walk to the edge, I no longer fall off. And perfect. That's going to be very important for our game. And you could tweak the values for the movement, the speed, the jump value. Again, you could adjust whether or not you use get access or get access raw. In fact, I actually want to use for horizontal get access. I'm going to save that, go back, and it just makes it a bit smoother. I won't get into the ways you can change sort of this get access, but if you're wanting the smoothing to be a bit faster or maybe even a bit slower, you can actually do that by going to edit, project settings, input manager, axes, and you can see these are all the axes that come by default. So the horizontal and vertical axes. I won't get into how you can change this, but you can adjust different sensitivities, dead. The nice thing about these inputs is that, for example, Unity supports controllers, and by default, you can use the horizontal and vertical axes with a controller using a joystick, which is really cool. And you don't have to do any of that. You could just plug in a controller and it just works. But if you are wanting to adjust the speed of those axes or something, that's where you can change it. But again, for this is perfect. So that's all we're going to do in this episode. It may not seem like a lot, but we already have a basic player moving, and we've talked a lot about Unity. We've already made our first custom script, and we're really doing a lot already. In the future episodes, we're probably not going to even have to learn as much because you guys already know how to create your own custom scripts. I'm going to be uploading this final sort of project at the end of episode 1, and I'll add comments to the code as well. So there'll be a link in the description for this project at this exact stage. So if you remember, there's a GitHub page for the final project, but there's also going to be a GitHub page for just what we have right now. So you could download that, look at that, and sort of compare. If anything goes wrong, you can check this final product versus yours at the end of this episode. Or if you're starting from a different episode, you can start from kind of the code right before. So yeah, check that out. And in the next episode, we'll be adding sprites to the player as well as getting a tile map going. Awesome. I hope to see you guys there.
GCC. We have the games.